Kids, here we go. Lots to do today. So let me find our, yeah, we are, let's just get it settled and organized. I need to figure out who's here. Alright. So it looks like everybody over there is here, everybody in the middle is here, and we're missing Austin. But that's good. Okay. So we need to finish this up today. So let's do that. So that next week we can start reviewing. We'll review for 2 days, and then we will have a test. Okay? So here we go. We are on page 33. We are on number 5. Solve no calculator. So this is kind of like one we did yesterday. First of all, where does this thing equal 0? Because it says less than or equal. So where does it equal 0? It equals 0 at 2. So I'm just going to equals 0 at 2. So 2 is going to be an answer, right? Now, there's a problem with -3, however. I'm going to mark that right now so I don't forget. Can x be -3? No. So whatever happens, maybe it won't matter, but I want to just keep track of that. So x can't be -3. If it's 2, it's 0. Now, look at this fraction. This is an absolute value, which means that it is always going to be positive. So if I want this fraction to be less than 0, the only way that can happen is if the top is negative, right? Because the bottom will never be negative. So what numbers make that negative? Anything less than 2? So what's my answer? Everything from negative infinity to -3. -3 to 2. Yep. So these problems that look so scary really aren't, if you look at them carefully.
Where are you doing that -3 on the graph?
It's in the denominator, right? Can't be -3, I have a 0 down there, and that's not good. Right? Okay.
Wait, why would it,
Are you gonna say something? What's happening?
no,
All right, you continue thinking, we're gonna go ahead. We wanna know, we'll come back when you think of what you're thinking of. Where is this thing 0? Where is it undefined? Where is it positive and where is it negative? That's the question. So for this particular problem, we want to figure out all of these things. So where is it 0? Can we do that first? Where will the value of this fraction be 0? -5/2 or 3. If you let x be either one of those numbers, won't your fraction be 0? Okay. Are there any places where it's undefined? Well, certainly it's undefined if x equals 4, right? I think there's another place where it's maybe undefined isn't the right word, but non-existent. Where else would this thing be non-existent?
Anything less than 3.
Anything less than 3? Because what happens if you put in a number less than 3?
It's imaginary.
It's going to be imaginary? Well, wait a second. What does that mean about this? Can we even put negative 5/2 into this problem? No. Because if you put in negative 5/2, it's going to be, well, that part's going to be imaginary, but since it's times 0, I guess it's okay. We'll leave it there. But it's really not part of the domain of the problem. All right, where's it going to be positive? All right, now I want you to think about this for a second. I'm going to look at it on the number line. We've said we can't be 4, and we can't be anything less than 3. So this is really the only part of the number line I can look at. If you put in a number between 3 and 4, like 3.5, what happens to your fraction?
That would be negative, because it'd be 3.5 minus 4 on the bottom.
Okay, but it's
Oh,
squared.
but then it's squared.
So it's gonna be positive on the bottom always, right?
Yeah, how would it be?
So I'm just saying, what happens if we put in 3.5? So if we put in 3.5, won't we be positive? So anything between 3 and 4 is going to be positive. What about stuff bigger than 4? Well, let's see, if we're bigger than 4, like 5, what happens to all these things?
Still positive.
They're still positive. So from 4 on, it's going to be positive? Well, wait, where is it negative?
Never.
It can't be negative because this guy right here will always be positive, agreed? This guy will always be positive. If it's real, it'll be positive. So the only way this thing could be negative is if that's negative. But the only way that can be negative is if you are less than negative 5/2. And you can't be less than negative 5/2 in this problem because they're radical. So there aren't any places where it is negative.
When it says when function 0, does that just mean when function is equal to 0?
What now?
When it says where is the function 0,
Mhm.
does that just mean like when x equals
Where does it equal 0? Yeah. All right, so now we've got some we actually have to solve. I want you to think about a couple of problems we did yesterday. Like back in the beginning of this section, like problem number 2, we had to solve it without a calculator, but basically we graphed that thing and looked for where it was above the x-axis. Do you remember doing that? Okay, so having that 0 there was very handy because when you're talking about positive and negative, 0 is kind of your point, right? You're either greater than 0 or you're less than 0. So before we do anything else with this problem, let's move the 3 over to the other side. Now, we're doing this problem without a calculator, guys. So 0 is probably the best way to go. Get a 0, even though you're thinking, oh man, really? I need a common denominator now? Yeah, we'll just get a common denominator. So our fraction will have a common denominator of x minus 2. And on top, I have x plus 1 minus 3x plus 6. Are you in agreement? So, and now less than 0. So negative 2x plus 7 over x minus 2 is less than 0. Oh, did I make a mistake?
No, I just have a question. So how come if you multiply the whole thing by x minus 2, the x minus 2 doesn't cancel out
Yeah.
for the x plus 1? Like the denominator doesn't cancel out.
I'm not. I'm getting a common denominator. I didn't multiply by anything.
Okay.
This isn't, well, I did top and bottom, but I can't multiply both sides of an inequality. Oh, if you thought you were gonna multiply this over to here, forget that, people, because I don't know what x is, right? And doesn't it matter whether this is positive or negative, how I handle that symbol? Yeah, you can't do that in an inequality. No, if you thought, oh, I'll just multiply both sides by x minus 2, nope, because you don't know what to do with that sign. Because you don't know if x minus 2 is positive or negative. And in fact, it could be either one. So you could do the problem this way, but you would have to set up 2 separate cases, 2 separate problems. What a headache.
Teachers, please excuse the interruption. Father Jomi will be offering Mass in the chapel in just 2 short minutes. If you're available, please come.
So if this were an equation, it equals, I would absolutely do that. Because I can in an equation. But in an inequality, whatever you multiply by, you have to know if it's positive or negative because you have to know whether to switch that sign or not, right? So what I've got here is a problem like this. 2/8 plus 1/4. What do I do when I have to do that? I get a common denominator. So that's all I did here. I made a common denominator. It had nothing to do with this fraction. I got a common denominator. Then I could add them together, and now I have this, which looks a lot like those weird problems we were just doing. So I want you to think about my number line. What do you know? Okay, what would make this problem undefined? What is it not good?
2.
So I'm gonna put an open dotted 2. Could this fraction ever actually equal 0? Well, it's not supposed to, but if it did have an or equal to on it, wouldn't that come from the top? So negative 2x plus 7, all those negatives, maybe I have to write it down. So 7 halves, if I put 7 halves in there, I would actually get 0. So I'm gonna put 7 halves on my number line. So in other words, I'm looking for the key numbers in the problem. The key numbers are things that make zeros. So 2 makes a 0, which I don't want. And then 7 halves makes a 0, which as it turns out I also don't want. But what those 2 key points have done now is split my number line up into sections, and I'm gonna figure out where they're positive, or in this case, where they are negative. So, pick a number over here, like, over here would be 0, would be a good choice. If you put 0 in for your x's, does it give you a negative result less than 0?
Yes.
Okay, so these numbers are part of the answer. Once you get your key numbers up there, and those key numbers came from finding where the top and bottom were 0, then just pick a number in each section and see if it works. So a number in there might be 3. So 3 makes the top positive and the bottom positive. Well, that's not good. How about 4? Out there, 4. 4 makes the top negative and the bottom positive. That works. So there's your answer. Everything from negative infinity to 2, or 7 halves to Lucy, what?
Could you plug in the x values into the original equation and see if it, like,
Oh,
works for that?
absolutely, absolutely, doesn't matter, doesn't matter. if I'm doing it down here, Lucy, I don't actually have to calculate it, I just have to know if it's positive or negative. If you're doing it based on 3, you're gonna have to calculate it, you're gonna figure out those numbers. Yep. All right, next one's exactly the same, here we go. Hopefully this makes a little more sense to you now. We're doing it without a calculator. Obviously, if we were graphing this on our calculator, it would be a different ballgame. But I'm doing it without a calculator. So I'm gonna subtract my 6 over. And I'm going to get a common denominator. So what's on top? 2x minus 3 minus 30x minus 6. So negative 28x minus 9. What makes the top and bottom 0? Negative 1/5 on the bottom. Oh, and on the top, I have to work it out. Did you get negative 9 over 28?
Yeah.
Okay. So here's negative 1/5, and here's negative 9 over 28. I think I got those in the right spots. Remember, zeros out here, so I think that's right. Those are my 2 key values now. Those are my zeros. Open dots or closed dots?
Oh, closed.
Closed on negative 9/28, but open on 1/5, negative 1/5? Because can a denominator ever equal 0? No, even with that sign in there, the denominator can't equal 0, but the numerator can in this case. All right. Mhm.
Is there like every other method still work?
Yes, good point. He said, I'm thinking back, we did that every other thing, and as long as you don't have any squares, like this square or something, that would change that. But as long as you don't have that, every other one, oh, I erased it, but look at the last example, wasn't every other one shaded? So that can save us some time. You basically only need to check one section, like out here, I'll check 0. 0's easy. 0 would give me negative over positive, which is not what I want. So that isn't going to be shaded, which means this one is, and this one isn't. And so my answer is negative 9/28 and negative 1/5. Very good, Peter, for remembering that. All right, gotta get a couple more done here. That one should be the main problem. All right, so look at the next one. Hallelujah! It's already got a 0, so I don't need to mess with it. I don't need to do anything to it. It's all set and ready to go. Where are my key numbers on this number line? I got one at 0, negative 3, and 5. So you do need to be careful that you're getting them on the number line in the right order. So your shading works out. Okay, so these are my key numbers. So now I'm gonna go in and I'm gonna figure out whether my dots are solid or open. Well, these two have to be open, but this one can be shaded because you're allowed to equal 0, and that's a denominator, or a numerator can equal 0, so that's good. Now, Peter, see that right there?
Yeah,
So that's a little problematic, so I think we'll still be okay, but I'm a little leery. So I'm gonna go ahead and, start checking places. So you wanna check one first? Now, just make sure you know where you're gonna shade if it works. So you're gonna put one in. Is one gonna make the top positive or negative? Positive. And it's gonna make both of these positive? So is positive over positive times positive less than 0?
No.
Okay, so I'm not shading that part. All right, let's try -1. -1 will make the top positive. It'll make that negative and that positive.
Yeah.
Positive over negative times positive, does that work?
Yeah.
Okay. -4. -4 makes the top positive. Negative. Negative? No. 6. Positive. Positive, positive. Is that less than 0? So it looks like the only area that works, unless I made a mistake, are you getting the same thing I did? So it looks like the only space that works is, be careful, you have to say -3 to 0, and then you have to say x equals 5. Because isn't 5 part of our answer? Because we shaded it, right? It just isn't part of an interval.
Does the every other rule apply for anything like this with an odd degree?
If the exponents are odd degrees, yeah, I think that would be fine, because that isn't gonna change any signs.
But
Okay,
even we have to check.
so we can use every other if the exponents are an odd.
I think so. I never do, because I'm just too worried, but I think that would be okay. Go at your own risk. All right, one more, D. This one is, we have a 0, so that's good, but we need to do a little work here. Please do not solve this. Somewhere in this chapter earlier, we had equations that looked like this, and we multiplied through by x, and everything was fine, we solved it and went on. This you cannot do that. Please tell me it makes sense to you that you can't do that. Because if you multiply by x, you don't know what to do with this. Because remember that rule that says if you multiply by a negative? Yeah. So you don't know what x is, so that is not going to work. So what are you going to do instead? You're going to get a common denominator. So this is going to become x cubed plus 4 over x. Would you agree with that? The top does not factor, at least not rationally. You can factor it with cube root 4 and stuff, but it doesn't factor rationally. But you can tell where the 0 is. The 0 for the bottom is a 0, right? You know that. Where's the 0, the key point for the top? The cube root of -4. Off the top of your head, anybody happen to know what that is? All right, I have to, it really doesn't matter because I know it's negative, right? So I know it's right here, somewhere over here.
Oh wait, no.
Not exactly sure where, but it's over there somewhere. All right.
No.
If I put in, well, let's start over here first. What if I put in a number like 2? What does 2 do to
Or
this?
like
Makes it all positive, so that's gonna work, right? what happens if I put in a number like the cube root of negative, or put in, what if I let x be like negative 1,000? Well, isn't that going to be negative? So that isn't gonna work, is it? Oh yeah, it will, because it'll be negative over negative, so that will work, yeah, that'll work. Because it'll be like negative 900 over negative 1,000 or something, or negative 900. Now what happens in here? Well, I don't think it's gonna work without going to our calculators, which might be a last resort. Can we logic this out?
Could you put -1?
Somewhere in here, would you agree is gonna be the cube root of -1 and -2 and -3? Aren't these numbers, well, do I have them in the right spot? Okay, so if I pick any of those numbers and I cube them, but then add to 4, isn't that gonna be positive? But this is gonna be negative, because these are, all the x's are negative. So that section won't work. Does that make sense to you? So our answer is everything from negative infinity to the cube root of -4, or everything from 0 to 1. So we did that without our calculator. We do not need our calculators for everything, but we will be using them for our word problems when we come back from lunch. Okay, one thing to tell you first, did we talk yesterday about your essay?
Essay?
Okay, apparently I didn't, so that's good. I'll talk